So, a Pythagorean triple is a set of three numbers. Actually, three, I'm going to say non-decimal numbers. Non-decimal. Yeah, you can say integers. It's just that says numbers right here, so integers sounds funny. Non-decimal numbers, yeah, also known as integers, that make this equation true. And that's our Pythagorean theorem equation. Are you guys familiar with any of these?
Yeah.
Yeah? Just throw one out. What do you got?
3, 5, and 4.
Is it 3, 5, 4? Or
I think so.
3, 4, 5?
3, 4, 5.
Yeah. 3, 4, and 5 work.
They have to be in a specific place on
Yes, they do. Which one of these is the C?
5.
Yeah, 5 is the C because he's the biggest. Okay, and there's one that we just did. What's the first triangle that we worked on? What were the numbers on that one?
First one?
There's a 24 and a 25.
Yeah, it was 7, 24.
7, 24, and 25. That was on the first one. Does anybody know of another one?
I didn't actually use the triples, I just know there.
Oh yeah? So give me another one. Give me another triple. Okay, these are something that you would memorize if you want to know them. Okay, and they make some jobs a little easier when doing the Pythagorean theorem. Okay, but if you remember the Pythagorean theorem, that way would always work. Okay, so let me give you guys an example. Okay, but first let me show you guys. Actually, I'll do the example after I show you guys why these are called Pythagorean triples. Okay, check this out. If I were to make a triangle, let's see, make a triangle right here. Okay, and I was doing the 3, 4, 5 one. Which one of these sides is the 5?
Hypotenuse.
Yeah, the hypotenuse. The hypotenuse is the largest one. Okay, now does it matter where the 3 and the 4 go? Nah, but this side looks smaller and that side looks bigger. So I'll do it like that. 3, 4, 5. So let's test it out. 3 squared plus 4 squared equals 5 squared. 5 is your C. Okay, and 3 squared is 9, 4 squared is 16, and that is 25. Is 9 plus 16 25? Oh, it's 25. Okay, now that works because that's it's a Pythagorean triple. It satisfies the Pythagorean theorem. But you know what's really neat? No. Oh, you can switch the 3 and the 4, yeah. But check this out. What is 3 times 3? 9. And what is 4 times 3? 12. And what is 5 times 3? 15. This, yeah, is another Pythagorean triple. It's just not simplified all the way. Does it work? I don't know. Let's try it. Which one is the C? So 15 right there. We'll put the 9 there and a 12 right there. Let's try it. What's 9? Say 9 squared plus 12 squared equals 15 squared. Well, I don't know. Well, maybe. So what 9 squared is 81, and then 12 squared is 144. What's 15 squared?
225.
Is it 225?
Yep.
I don't know for sure. Okay. Can you guys add 81 and 144? Do I get 225? Holy crap. So, in order to find this next one, what you just told me was you used the Pythagorean theorem, right? You took this and you went, 50 and, let's see, 14. You said 50 squared equals 14 squared plus something squared, right? And then you found that something, and you found it to be 48, right? Okay, so when you solved it out, that's how you did it. You used a formula. And that's cool, because it works. But there's a faster way. Yeah, use the triples. Okay, now I only listed 2 triples up here. I could list more, but, let's keep this video short. You guys remember this one right here? How did I get this one right here?
You multiplied all of them.
I multiplied all these by 3, right? Okay. You guys aren't seeing it yet? Can you get 50 using 25? How? Multiply by 2. If I multiply one of these by 2, do I get 14?
Yeah.
Ah. So what would the third one be? Yeah, you just go 24 times 2. You just have to multiply those by 2. Kind of neat, huh? You guys don't think that's neat? If you Google Pythagorean triples, it'll come out with a list of them. It's crazy. I think this is so neat. Okay, so 48 is your answer there, and you could have used a Pythagorean triple to help you find out just by multiplying all these by 2. Okay, now, the last thing I need you guys to do is this summary/reflection. Why aren't the following sets of numbers Pythagorean triples? And I want you guys to guess if you don't know, so try it. First one. Oh, sorry, that's enough time. The first one is not a Pythagorean triple. Why?
It gives you a decimal.
Yeah, decimals. Okay, decimals. Actually, so because they're decimals, oops, not a Pythagorean triple. Decimals. That's all I'm gonna write. I'm not gonna write a bunch of stuff. Oh, that M is hideous. What can I multiply all these by though, so that there's no decimals? Does anybody know? That's just like an extra question.
2.
Yeah, 2. What's 2 times this? You guys know? Like you have 250, someone gives you 250. Yeah, it'd be 5. And what's 2 times this?
4.
5, 4. Does this look familiar?
3.
What's 2 times this? 3. What? Now it's a Pythagorean triple. Okay. All right, but it can't be decimals. All right. Is this a Pythagorean triple? Why not?
Doesn't satisfy the theorem.
Yep. Doesn't work with the theorem. Theorem. And is this a Pythagorean triple? Nafu. Why?
Same thing.
Same thing. Okay. Let's do a double line thing to represent the same thing. Good job.